Evaluation of a financial portfolio visualization using computer displays and mixed reality devices with domain experts. Comparative studies between 2D and 3D visualization have found interesting benefits for VR-based systems, while Smallman and others found that users of an air traffic control console were faster in accessing information in a visual search task. Users of a VR-based system were able to do more exact spatial judgments. Millet and others used 2D and 3D visualization in VR in a self-tracking study and found that users were both more satisfied and had more insights in the VR-based system. Butcher et al. Report that the use of VR can create a more engaging environment in visual analytics than a 2D-based visualization. Torrey and others suggest that the combined use of 2D and 3D provides most benefits. However, existing research strongly focuses on virtual reality. With the advent of mixed reality devices such as the Microsoft HoloLens, developers have been faced with the challenge to utilize the third dimension in information visualization effectively. Generally, research on stereoscopic devices has shown that three-dimensional representation can improve accuracy in specific tasks, such as network visualization. Yet, so far, the field has remained mute on the underlying mechanism. To address this research gap, we designed an empirical study. Our study aims to systematically investigate the differences in users' perceptions between a regular monitor and a mixed reality device. We used a mixed method approach in collaboration with users to design a suitable visualization of financial data that works both in 2D and 3D. We used physical prototypes to understand the benefits and drawbacks of spatial data representation. The visualization should help portfolio managers to identify stocks that are at risk because of associated high carbon dioxide emissions. However, the task requires to understand multiple variables at once. We tested a wide spectrum of object types for data representation regarding suitability. Users must evaluate CO2 emissions against the weight of a stock in a portfolio, and relative changes in emissions and value to assess risk adequately. This requires both understanding individual stocks, whole business sectors, as well as overall distribution. We tested different virtual placements of visualizations, such as spheric projections, virtual workstations, full room utilizations, free-floating visualizations, tabletop visualizations, and landscape visualizations. Lastly, a tabletop visualization using a force-based B-swarm plot was chosen together with the domain experts. Interaction was realized using both gaze and gesture detection. While the 2D visualization used mouse input such as hovering and button clicks, values and names of stocks were anonymized but drawn from a similar distribution to prevent effects of prior knowledge. We tested accuracy with regard to position, size, and color, using single and combined tasks. In a real-life within-subject experiment in the field with 28 investment bankers, we assessed subjective and objective task performance with 2- and 3-dimensional systems respectively. To prevent ordering effects, we used different portfolios between tasks. As the size of the visualization in the mixed reality device depends on head position, we compare the distributions of actually shown stimuli with respect to the relative horizontal position. Here, no difference becomes apparent, not between portfolios and not between devices. A look at bubble size shows that a 2D monitor allows for smaller bubbles than in 3D. To compare color representations, we used CIE 2000 distances. We see slight differences in the used range of colors between devices. When participants were asked to report the top 3 data points with respect to radius, position, and color hue, we see no effects of device or portfolio on performance. In a conjoint task rating 2 variables at the same time, we see that for judging radius and position, there is an interaction between portfolio and device, yet no overall effect. When looking at position and color, 3D performs significantly less well. In the last task, participants were asked to evaluate the data with respect to 3 variables. Here, 3D also performed less well, although the effect is only significant for portfolio number 17. We also looked at subjective evaluations, asking for perceived usefulness and perceived ease of use, yielding no significant differences between device types. When rating the user experience, users found the mixed reality device to be less boring and more enjoyable. Other measures showed no significant difference. Overall, we can say that our user-centered design process produced a visualization that works in 2D and 3D and is acceptable for real-world end users. We believe the differences in performance between devices can be attributed to the differences in color resolution. Here, the mixed reality device suffers from a smaller color range. To strengthen our findings, we think future experiments should use just noticeable difference setups to determine how large the differences between display types actually are. Ultimately, we think that in the future, mixed reality devices could be used in mobile multi-user environments to replace large screens on the go. To summarize, we found no significant differences between 2D and 3D visualizations. Increasing task complexity reduces the accuracy in the mixed reality setting. 3D was perceived as more enjoyable and less boring.